Is voice okay? Fully audible? No. Fully audible? Okay. Voice clear? I'll start now. What is the class number given today? Anybody can tell? I see here. 148. BSK class 148. This is class number 5, I think, correct? I think I given in thumbnail. Class 5. Just check it. Class 5 or not. 148 is BSK class. That is full series. I think in that thumbnail, I written class 5, I think. Conclusion I written. Conclusion. Class 4 or 5? I think 5. Is it class 5 there? In the conclusion? No, because small information. I think class 5. Today written. Today written. Most probably class, otherwise I have to go and check there. You can see there and tell. Or I have to go out and come once I come back. Not there. I cannot see here. 1 minute. No answer. Class 6 today. Are you sure? Just a minute. I do not want to give any. Okay, 1 minute. I should not give wrong information. 1 minute. Yes, class 6, correct, okay, class 6. Just confirming it because today is class 6. Yes, okay. Just a small information first before I start. See, today's class for the regular batch, that is a BSK batch, it is BSK class 148. General public, they don't have to bother. Why? This is my course. So 148 class is not there. Only part of that one. Sometime I consider in YouTube some chapters. So you don't see this one. In the playlist I will write combined effect of axial force and first biaxial BM, then uniaxial BM. That is, last class was class 5. Today's is class 6. You see thumbnail. In thumbnail you can see for general public, this is important. This you can't make out, class 6. Now, class number 147, that is the same BSK class 147. Class 5 was taken yesterday. Make a note. But what happened there was, okay, there is not a mistake. Everything I explained correctly, full correctly. S1, S2, technically everything is okay. But when I put the final result, by mistake, instead of S1, I wrote S2. It hurts me actually. See, just when I explained, I told S1 only, very clearly. See, my hand was moving like this. When my hand was moving like this, how I can take S2? It is S1. Everything technically told, even depth, width, all correct. But after some time, maybe the closing part, I wrote class 6, I wrote S2 there. But I don't like it. So this is actually made unlisted. Now I decided, because this combined action, if not today, one fine day will attract lot of audience. It is a very critical one. See, I made unlisted. So if general public cannot watch, you can watch. Those who are in the group, you can watch, because unlisted means link is there with you. I have given very thorough explanation. You can go through it. End portion, replace that S2 by S1. That's all. But general public, what I will do now is, see, this is not available for public. Available for public. So no problem. Either today or tomorrow or before next Tuesday, when I take my next class, I will upload same BSK class 147, then class 5, I will put here revised. Something I will write, revised. So, and add it to playlist. Therefore, then only I will put this into the playlist here. So, you go through there. So, today I am going to conclusion. Conclusion means proof, everything proof comes here, class 5. Now, today's class conclusion, proof is not required. There are so many people who does not want proof. They want what? They want summary. So today I am giving summary and conclusion. Therefore, what you do is attend this class. Later, once again go back to the newly uploaded class, class 5. I will tell briefly how much I explained in the class which I made unlisted. That much I will not explain there. And one more thing, since it's a recording, it will take lesser time. Here I have to ask you questions, you have to answer, etc. Nothing is there. So this you get once again. Those who are regular group, study this one, study this also. What is there? General public, this will come. Okay, now I will go to class 6. Whatever told in class 5 last time, which is technically removed, it will be uploaded maybe after 1 or 2 days, before Tuesday. Okay, start now. See, final conclusion. Remember now? I will write here now. See, first of all, make a note. What we are discussing now is axial load with uniaxial bending moment. Uniaxial bending moment. That is, uniaxial means BM only about one axis. Or you can write one more way. Tell what? Or load, or you can tell what? Some other name. You can call it eccentric load. Eccentric load. Over. Remember, just make a note. If the load is eccentric, it can be replaced by axial load and BM. But one important, eccentric load, but eccentricity only about eccentricity, okay, with respect to only one of the principal axis, principal axis. Because I will tell the reason here. See, make a note. See, this is the axis. This is one more principal axis. If the load is here, it is eccentric with respect to this axis. See, from this axis, no eccentricity. This will create load, axial load with this way BM. Or if the load is acting here, it will, when you replace here, it will become load, axial load here with this way BM. But by chance, if the load is somewhere here, what happens? It is eccentric about both the principal axes. Then when you replace here, it will give you what? It will give you axial load with biaxial bending. That is earlier. So our discussion is uniaxial or eccentric load. I will write one more. These all, those who are serious, you should all write this one. Or further, eccentric load, I told what? Eccentricity, I write once again. Eccentricity with respect to only one of the principal axis. One of the principal axis. Only one, not two. That will become axial load with uniaxial BM. Now, this is very, very important. Now, further make a note. Further, at present, you write, we are discussing this effect on cross-section of a vertical member. Not footing, cross-section of a vertical member. See, I told last time. Suppose a column, easy to understand, say column. If you apply all these on a column, what will happen? Tell me. See, column, when you apply load, it will give compression. BM, one side compression, one side tension. Then, this is a member. It can take, see, if I apply BM this way, see, this will get compressed. It can resist it. This will come, tension will come. It can resist it. So we are studying effect on, at present, the effect of P and M. We are studying on cross section of a vertical member. Vertical member, say column, short column. I told short column. That is what? Cross section can resist what? Can resist both compression and tension. Compression and tension. But later, that is tomorrow, next class, I will make once again conclusion. There I will study, or I will consider, I will not study, I will explain, you study, effect on not cross section of a column, load transfer from column to footing, and then footing to soil, or footing to soil. At that time, the cross section is this way, plan dimensions. There, uniaxial, biaxial, both I will explain. There, if you get in the column, when you get compression, there also compression. But we will use the word, it will press the soil. It is required for foundation, retaining wall, or dams, etc. Very, very important. What I tell compression here means it will press the soil. Yes, no problem. If the soil is pressed, it will give upward pressure. So what you get is, see, when it will press the soil here, it will give you upward pressure. No problem. So it is equivalent to our compression. But other side, if it is still compression, good. But if the excentricity is too much, or the BM effect is more, other side, here we will tell tension. There, not tension. Tell the word. In footing case all, we don't use the word tension there. See, because, see, when you place something in contact here, compression can be resisted. Tension, see here, tension cannot be resisted. Because, except in the case of steel base plate on pedestal with the anchor bolt. If you provide anchor bolt, then tension can be resisted. That is separate theory in steel. In general, we will do one thing. We will limit to footing in contact with soil. That's all. Not with anchor bolt. We will discuss footing of what? Either a column, RC column, or a steel column, or retaining wall, that is called base slab, or what? Masonry dam, subjected to vertical load and water pressure from side. Or retaining wall comes, the soil pressure is there. There, if what you call tension here column can resist tension. Today's conclusion, we will take tension. But later, there, compression means it will press the soil. Pressure will come upward. Tension means what you discussed today, tension, tell me, that contact cannot take tension. Therefore, tell what is the word used there? What is the word used there? Lifting. It will get lifted. Means it leads to instability. That's all. I will not tell once again in that case. I will tell already told in previous class. So make all these notes. Okay, now start. First, before you start, I think start. Volume. See, what happened is the volume got increased here. Then you can see double sound. Okay, okay, I put here. Now, before that, last note. See, if the cross section is like this, same thing later also. Cross section is like this. See, what I will do is, actually it's isometric. Or if you write plan, this is isometric actually. See, isometric view. Or actually plan. Here I can show the load and show the BMs. Here load is like this. BM is like this. You can't show it. So you put arrow mark like this. Okay, now see, I will draw this is the note, very important. Remember, later I will not tell repeatedly. You should make all the note. See, now I will call this side as S1. I won't call breadth and depth. I will call this side as S2. Then, here, so therefore, this will become your S1 here, 3-dimensional S1. This will become S2. Now, in the cross section, see, this I am calling axis 1, 1. I don't call XX, YY. This I will call axis 2, 2. Full conclusion I am making. I am making full conclusion now. Okay. So 2, 2. Now, axis 1, 1 is parallel to S1. Axis 2, 2 is parallel to S2. Okay. Now, this is CG. I won't write here. This is 2, 2. This is 1, 1. 1, 1. See, now, I will write here and keep on writing and rubbing it now. We are discussing eccentricity only with respect to one of the axes. So, at the end I will come to that core. See, this way. When biaxial is there, then it is called, one core will come. I will tell later. Okay, start now. See, if now we first, last class full we discussed eccentricity with respect to 2, 2. So, load is moving like this. But where? Not here. Load will go this way or this way. It is somewhere here, anywhere P. See, somewhere here P. When you replace by axial load here with the BM, it will become what? It will become, see, I will put here now. What will happen? When you replace it by axial load and BM, this P will come here, P, and it will create a BM like this. See, this way, you cannot see it. This way, M. This M equal to P into E. Now, one small mathematical concept, again and again I will not tell, go through this again and again. See, in analytical geometry, see, when you write this is YY, when you write this is XX, remember, if you move this way, it is called X coordinate. If you, anywhere, see, if you move this way, it is called X coordinate. If you move this way, it is called Y coordinate. Now, remember, once for all, actually you know it, X is distance measured along XX. But remember, distance measured along XX. But if you want to refer an axis, X is the distance measured from, tell me, which axis? Not from x-axis. If you tell x is the distance measured along x-axis, this way, this is called x. But its x value is measured from what? Y axis. See, y you measure. Y is the distance measured along y axis. So it is from x axis. Or common sense. See here. If I walk this way in the floor, horizontally if I walk with respect to a vertical wall. See, I will tell, I am 1 meter from the wall. Now I am moving horizontally. I will tell, okay, I will turn here. There, okay, the wall is somewhere there. Okay, or I will think, some wall here. See, you can't see it. There is a wall there. That wall, I will tell, I am at 3 meter now. I am moving horizontally along x, but I am moving measurement of distance from the wall. So it is along x, but the movement is about y. So when the BM comes, the BM will be about y. Same way. See, if I take a lift, suppose imagine I stand here, there is a lifting arrangement. If I am getting lifted here, I am moving along y, but I am moving with respect to what? From where? Moving vertically means measurement from a horizontal plane. I am moving with respect to floor level. Clear? Therefore, x distance is along x-axis, but measured from y. So any BM comes is about y. Y distance is measured along y, and any distance along y is measured from x-axis. Or if any BM comes, it is not along, it is about. It is about x-axis. Full clear? Now lastly I will tell. See, here only. If I move this way, or if any distance considered this way, it is distance considered along the axis 1 or along S1. Along S1. If I consider along S1, any distance here, its measurement is from 2 axis. See, this way. Not 1 axis. If you move along 1 axis, it is along S1, but with respect to 2. Same way. If I move along 2, then measurement is along 2. So it is called what? Measurement is along 2. I will call this as E2. This is E1. Why? See, this is, if I place here, this distance is extension, or I can tell E1. I will tell E1, but E1 is from 2. See, EX is from YY. EY is from XX. Any X distance is from YY. Any Y distance is from XX. So, I will call this as E1. If I call E1, not now, when I consider biaxial, if I call E1, it is measured along 1, but measured from 2. And when the load is moving this way, anywhere you place, BM will come this way. If BM comes this way, see here, it is about 2. And for BM about 2, structural breadth is S2, structural depth is S1. Structural breadth is parallel to the axis. Moving along 1 is about 2. Okay. Structural breadth is S2, depth is S1. If I move this way, it is, moment will come this way. Axis is 1. For axis 1, structural breadth is S1, structural depth is S2. Or there is an easy method for you, I told. If the load is moving this way, see, if the load is moving this way, or if moment, then moment will come that way. See, moment will come this way. Moment or bending moment. When BM this way, use the wrong word. Actually, BM is not along. BM is about. But still, easy to understand. See, if it is this way, how your hand is moving, along that one, whatever dimension is there, that is structural depth. So, any movement this way or any BM like this, structural depth is S1. Any BM this way, see, my hand is moving along S2. Structural depth is S2. Other one becomes structural breadth. I will not repeat once again. Fully clear? Fully clear means I will go to conclusion now. Okay, that is correct. Structural depth is the cross-sectional dimension perpendicular to axis about which moment is acting. That is technical. That is technical. People find difficulty. When you use the word about this axis, people find difficulty. They don't understand. Actually, structural depth is the dimension, what? Perpendicular to the axis. See, you know, in case of beam saw, when bending is this way, it is about neutral axis here. This is the depth. That is technical. I told last time. In the class number 5 I told. See there. I am telling easy method. So easy method now is simple. You move along S1. Moment is about 2. Move along what? 2. BM is about 1. And move along 1. Your BM will come this way. It is about 2, but structural depth is, how is the BM? This way. For this BM, this is structural depth. How, see, when you show that BM, how your hand moving along the, actually along word is wrong. Along that one is structural depth. Very simple. See, that is, see here. If you write this way BM, my hand is moving like this. So, this will become structural depth. Whereas, if I move like this way, then this will become structural depth. Then automatically, if this is structural depth, this will become width, then this will become width. Tell me, lastly, full clear means I will go to conclusion now. Full clear means I will go to conclusion. I will go to conclusion now. I told today's class is a conclusion. Okay. Start. Now, this all I'll remove now. See. I will put full diagrams. After giving all the diagram, I will take a small break. Why? You see correctly and comment. Yet everything is clear. Then I will go to that middle third rule. See, first. Or I will tell you first middle third rule only. Now itself, I will tell middle third rule. Middle third rule. This is only for uniaxial or what? When the load is acting along one of the axes. That is, eccentricity is with respect to only one principal axis. One principal axis. See, now, just see. Yesterday I told you, if I write the plan here, middle third rule. Okay, see now. This is S2. This is S1. See correctly? S1. Now, this is the axis 1, 1. Don't by heart. This is the axis 2, 2. You consider now, load P, axial load P, or load P, eccentric load P, okay. Consider eccentric load P anywhere on axis 1, 1. Axis 1, 1. It can be either that side or this side. Say, randomly I will place here, but not here, P. Then, this is called eccentricity E. Why? When the load is moving here, E is the eccentricity. E is the eccentricity along 1, 1. It is along 1, 1, but about 2, 2. About 2, 2. That is, any M will be about 2, 2. Now, this will be equal to, see, or I'll remove this one now. Sufficient. Already explained. You write it. I'll remove that one. This you can put equal to what? Some will tell this is told 1,000 times. Okay, now see. I will put here 2, 2. This is 1, 1. Both I will write 1, 1. Remember, your load here will be shifted here. It will become axial load P with the BM M. This way. See, this way M. For this M, your structural depth is, which one, tell me? For this BM, tell me, what is the structural depth? S2 or S1? This is what happened yesterday. In the end, by mistake, oversight, everything correctly I did it. While writing lastly, I just took S2 by wrong dimension problem. S1. Structural depth is S1. S1, that's all. Therefore, structural breadth equal to S2 over. Now, see here. Now, what is the stress here? Then, axial load will give everywhere compression. BM will give compression this side, tension this side. So, then, see. This is axis. Now, see, now putting axis here. Along this edge, see, this way, along this edge, sigma resultant equal to plus P by A plus M by Z. Whereas, along this edge, see, here, along this edge, anywhere along this edge, here, anywhere, see, when you consider this BM, stress variation is along the structural depth, I told you. Anywhere along this edge, sigma resultant is plus P by A. Remember, our sign is compression positive. Plus P by A minus M by Z. Now, therefore, if you place the load anywhere this side, whether near to axis or away midpoint, or as the load goes this way, permanently, this will be compression. Why? It will come plus only. Why? Compression. You write here. Why? Both are plus. But this will be, we cannot tell. Here. If your P by A is more than M by Z, then tell the answer. If your P by A is more than M by Z, then sigma resultant will be positive. That is, it will be compression. And if your P by A is exactly equal to M by Z, then, I'll put here now, see, you write this way, then sigma resultant will be 0. Later, it will become on the verge of lifting. Whereas, if P by A is less than M by Z, see, axial force more predominant than bending moment. Yes, compression. Axial force and bending moment both are equally predominant. 0. Axial force is less predominant, BM more predominant, then sigma resultant will be negative. So positive means compression of, no sign here, P by A plus M by Z. 0. Negative means it is M by Z minus P by A. Why? Because I told you already, suppose 6 plus 8 is plus 14. Suppose you write 6 minus 8 is minus 2. When you put minus sign, it is 2. 2 is what? 8 minus 6. This also I told yesterday. Now, for P by A to be more, for axial force to be more predominant than BM, you should write everything. Condition is your eccentricity E should be less than how much? S1 by 6. Actually, eccentricity means always structural depth by a number. Structural depth is how load is moving. Okay, S1 by 6. This is the case when E equal to S1 by 6. This is the case when E is more than S1 by 6. See, common sense, I will explain for you now. See, I will explain first. Eccentricity more means danger. That side, lifting chance for footing. See now, I will explain to you. See here. If my hand I will spread as much as possible. See, full book I will cover by base. If it is axial load, no BM, full compression. Now if I shift the load this side, see, then that side gets more compressed, here less compression. See, suppose load is not too much more, slightly shifted, then still there will be compression, heavy compression here, less compression. One particular portion, see here, one particular portion, if I move here, you can see now, this end is about to be lifted. But if I shift further, see now, see now, if I shift further, if the eccentricity, see, if I stand this way, only compression. If I slightly bend, still see, my shoes, both are still compressing, but front side more pressure. But if one particular portion, the back side is about to be lifted, if I bend further, see, I lose the balance, I will fall down. Why? Back side gets lifted. So, for stability, you want eccentricity more or lesser. Tell me. Once again, reason is there. For stability, you want eccentricity more than structural depth by 6 or lesser. We want lesser. Common sense. Why? Eccentricity is a danger. It is bad. See, eccentricity is bad. See, sometime after night 7:30 or 8 o'clock, people walking. Normal people will walk freely, not eccentric. Sometimes people lightly, they will do this way. Sometimes they will bend this way, keep on bending, they will fall down. Why? Overdose. If it is an overdose, that overdose is eccentricity. Clear here? That overdose, you know that one. That overdose will make the person eccentric. See, in common language, you tell how is the person? Good person. Sometimes you tell he is slightly eccentric. Means what? Slight, I think it is a common name. He is slightly eccentric. Heard of it or not? When you comment about a person, okay, that person is okay, but he is slightly eccentric. Have you heard of this word? Slightly eccentric. Yes. But too much means that person is useless. He is mad. They will tell he is mad. Normal person, normal. Or some will tell slightly eccentric. Okay. Sometimes behaves oddly. And that person, he behaves full madly. That is high eccentricity. Slot of time. Heard, sir? Heard, sir? What? What is slot of time? Slot of time. It's not clear. I don't know what is slot of time. Any problem? I saw one. Slot of time. Lot of times. Lot of times, yes. Lot of times. See, you tell normal person. What? Correctly axial. Then axial, correctly standing. Slightly eccentric. Okay. Oh, this is too much eccentric. So, we want load not go beyond the limit. Now, how to decide now? See, if E is less than S1 by 6, what happens now? See, if the load is, see now I'll put one more sketch for you. This all sufficient now. I'll put one more sketch for you. See, all this over, all explanation over now. You go through patiently entire class. Then only everything will be clear. Not randomly study. See, I'll explain here now. Now, last part, see, I am discussing, this is the axis only I have seen so many times. People get confusion about the axis. I don't know why that confusion. That axis confusion should not be there. Okay, leave it now. I will do one thing now. This is your S1. I am moving along S1 means this will become your structural depth. Structural depth. See, if the load is here, no problem. Why? Small eccentricity. It is plus here, high value, still plus here. Why? Still plus here. Now, if the load goes here, it is plus here still, but little more plus. But this will become one particular slot, it will become 0. If the load goes further here, it will become further more, this will become negative. Now, you know that 0 comes when the load is here, when P is, this is the E. Tell the answer. See, E. See, this I will put A, B, C, D. I will put A, B, C, D. For resultant stress anywhere along AD to be zero, tell me what is the value of E? First tell the answer. For resultant stress anywhere along AD to be 0. See, E equal to how much answer? With respect to this dimension. S1 by 6. S1 by 6. Note, result. If your E is less than S1 by 6, then along AD also what? Along AD also positive. Positive. That is good. Good. If it becomes E by S1 by 6 becomes 0. Whereas if your E is more than S1 by 6, then remember later danger for footing. It is danger for footing. Then tell an answer. Then here means strength of materials. Here strength of materials. What? Along AD sigma resultant will be what? Tell me. As per strength of materials, along AD, sigma resultant will be what? As per tensile. It is tensile as per strength of materials. Whereas later for footing case, For footing case, we write it as what? It will get what? It will get lifted. And here you will tell, for when it's S by 6, we will tell later that it is about to lift. Oh, about to lift. If it is equal to S1 by 6, more we see about to fall down. If you go further, gone. Sometime when people take dose, he will reach a stage when he is about to lose normal behavior and he will slightly become what? Dozy. If he takes furthermore, he will go out of control. If he takes lesser amount, what I will not tell. Sometimes people, limited amount, nothing will happen. Why? Small amount, don't take actually, not that way I am telling. Example, little, some people take little. Why? They know their problem. Little for enjoyment. Okay, for them, they are normal. But if they take one particular stage, it will become, he is about to go from this stage to other stage. Still not go. Little more means he will start talking nonsense. Then he will start talking nonsense. Okay, now, all over now, I will write the final conclusion. See, 1 minute now. This is the story for eccentricity this way. Now, tell the answer. It is possible that eccentricity can be this side also. It is any side. You don't remember right side, left side. See, instead of there, if the load is here, tell what will happen. Tell me then. Then, if I put A, B, C, D, tell me which is the edge which will get lifted. If I put the load this side, tell me which is the edge which will get lifted. If this eccentricity is too much, if it is too much, same condition, which is the edge which will get lifted? BC, then BC will be in tension. Or later, we will, in case of foundation, footing case, we will tell, will lift. Therefore, see, I will put the final verdict now. Final conclusion. If this is the rectangular section, this side is called S1. See, final conclusion. I wrote in the thumbnail conclusion. If this side is S1, this side is S2, A, B, C, D, I will write here, whatever way you want, A, B, C, D, then I have to always mark the axis. Why? 1, 1, 2, 2. This 1, 1, 2, 2. You consider load moving along this line. From here, see, you divide this entire length into three equal parts. This is what? S1 by 3. This also equal to S1 by 3. This also equal to S1 by 3. Somewhat slightly out of scale. No problem. Okay. Divide into 3 parts. Okay. Almost okay. All are equal. See, when you divide into 3 equal parts, it becomes S1 by 3. Then, if the load goes, see, now project this point here or project this point here. So, if the load is anywhere here, I will do one thing now, I will make dark here. I will give a name as A, B, C, D. I will call EF. Now tell the answer. If the load P is anywhere between what? E and F, then there will be what? If the load is anywhere between E and F, see, if the load is, see, correct now, then see now distances here. If it is S1 by 3, this distance becomes S1 by 6. This will become S1 by 6 because total length is S1 by 3, 1/3. See, this is actually this is what? This is 1 by 3 of S1. So that this is S1 by 6, So if the load is anywhere between E and F, that is in the middle, what? In the middle, 1/3, I will tell, in the middle 1/3 length, 1/3 middle, 1/3 length. Length means what? Length along which, length means what? Along which load is changing position, not structural length. This length is not length of member, cross-sectional length. Load is changing position, changing position. So then there will be in the middle 1/3. Then answer now. I'll let here. Then as per strength of materials, what will, there will be what? There will be no tension anywhere. No tension anywhere. Anywhere. Correct? No tension anywhere. If it is what? Anywhere in between. No tension anywhere. Full compression. Full compression. Okay. And later, in case of footing, what you tell? Then no, you can tell what? No lifting. No lifting. Everywhere, everywhere, soil gets compressed. Soil gets compressed. Compressed. Therefore, good. Compressed. Full clear? See, if the load goes beyond some, this is not required now. If the load goes beyond E here, that will lift. If the load goes beyond F here, this will lift. So as long as the load is in between E and F, there will be no lifting chance. Correct? Clear or not? Clear. Okay. This is called what? This principle is called what? This principle, that is, if the load occupies, you write yourself, if along any one of the axis, if the load occupies any slot or any position which is what? Not more than L/6 this way, you write correctly if you are interested. L/6 this way or L/6 this way, or it is anywhere in the middle what? Anywhere in the middle 1/3. Middle 1/3 length. Length means not your dimension length. Middle 1/3 length along which load is moving, then there will be no tension in strength of materials or no lifting for footing case. This is called middle third rule. Fully clear? I won't repeat once again now. All this you write. Full clear? This is called middle third. Middle third means this length you divide into 3 parts. But axis comes here. In the middle third rule, load can occupy any slot either side in the middle third. But from center of gravity should not go beyond how much? Not 1/3. Lengthwise, it can occupy any slot in the middle 1/3. But from center of gravity, load should not go beyond how much? 1/6 of the length. Clear? 1/6 of the length. Here length means structural depth. Remember, don't remember width and structural depth. And also make a note. If you should write, lastly add one more. If the load is exactly here, then that edge is about that edge, resultant stress will become 0 in strength of material subject. Why? Stress language. Stress language, if the load is here, see, then if the load is this side, lifting is that side. Here, this stress resultant here equal to 0. Whereas, if the load goes further this side, that edge will be in tension in strength of materials, whereas it will get lifted in case of footing. Same way, if the load is exactly at F, then this edge is what? Will be resultant stress equal to 0. In what? In strength of materials. In footing, you will tell this, if the load is somewhere here, this edge is about to be lifted over. Now, if the load goes beyond this one, or if the load goes beyond F here, strength of materials, this will be tension. If the load goes beyond this one, strength of materials, this will be tension. In footing, if the load goes beyond this one, this edge will get lifted. Or if the load comes this side will get lifted. This is what? Along 1, 1. In the same way, you don't have to prove now direct answer. What? Direct answer. Same way, remember. In the same way, right? In same way, by chance, you write here. If the load is acting, see, not acting, it's placed. This is the axis 2, 2. This is the axis 1, 1. Write directly 1, 1. Little scale required. Okay. No proof required. This is your S2. This is your S1. Now, if the load is shifted here or here, if the load is moving like this, along right here, if load is placed anywhere along 2, 2, along 2, 2, then BM will come this way. Then tell me structural depth, how much? If the load is placed anywhere here, the BM will come this way. Then ABCD, reverse will come. Now earlier your discussion is one edge AD, one edge CB. Now edges are one edge AB, other edge DC or CD. Okay, now tell what is the structural depth. Structural depth because what? S2. Now your eccentricity will be with respect to what? E will be in terms of S2. S2. Do one thing. Again, I will remove this one, not required. Divide this entire length into 3 equal parts. 3 equal parts of S2 by 3, S2 by 3 and S2 by 3. See here. Now see here. I will call the point A, B, C, D over, I earlier called EF, I will call GH. G I don't want. Why? G is center of gravity. I will call HI. Then if the load is write a note, you should write. Now your reference is when the BM comes this way or this way, your edges are either this edge or this edge. This is the edge under discussion. This is the edge under discussion. Remember. Now this is equal to S2 by 6, S2 by 6. Or if the load is placed anywhere along this axis, in the middle, now this total will become, it's here, S2 by 3. See, the total range is S2 by 3. This will be S2 by 3. S2 by 3. If the load is placed anywhere in the middle 1/3 length of S2, then both this edge and this edge will be compression, or in footing press the soil. But if the load is here, then this side is compression, this side strength of materials, resultant 0, or in footing about to be lifted. If the load goes further this side, then strength of materials, stress will be tension here, or footing case, this edge will get lifted. Or if the load comes here, if it is anywhere in this portion, both are compression. Okay, now if the load is exactly here, then strength of materials, that DC stress will be 0, or footing about to be lifted. If the load goes further this side, then the DC will be tension if it is a cross section of a column, whereas footing case it will get lifted. So if you move this way, it is middle 1/3 of S1. If you move this way, it is middle 1/3 of S2. XLD is not 1/3. 1/3 is the middle portion. In between them CG comes. See, when the portion is 1/3, CG comes here. From CG either side 1/6. So eccentricity limit for no tension or no lifting in footing is always what? 1/3 or 1/6, 1/3 or 1/6. eccentricity limit is what? 1 by 3 or 1 by 6? Eccentricity limit is what? 1 by 3 or 1 by 6? Eccentricity limit. You are not answering. Eccentricity limit is, answer first. Eccentricity limit. See, you are wasting time. You should tell, I am asking eccentricity limit. See, why no? Any problem? Any audio problem? See, if you don't answer, I get doubt whether audible or not. Then what I am talking is wasted. Later, if I find that it is not audible, my class is gone then. So you have to answer at least. What is this? I told eccentricity limit. Again, see, if this is the confusion, what I can do? 1 by 3. Eccentricity limit is not 1 by 3. 1 by 3 either side together. 1 by 6. Eccentricity limit is 1 by 6. Where it? E limit is 1 by 6. But that range either side together, where you can place the load, the either side to either side distances, you make a single stretch, or you tell the limiting range. Limiting range in distance wise is 1 by 3. From center of gravity, see, the length where you can place the load is middle 1 by 3, middle 1/3. But from CG, not more than 1 by 6. Or imagine, if the structural depth is, for example, 9 meter, then load should be in the middle 12 meter. If structure, or 15 meter. If structural depth is 15 meter, load should be in the middle 5 meter length. But from center of gravity, either side, load should not go beyond how much? See, if depth is 15 meter, then load should be anywhere in the middle 5 meter. But from center of gravity, load should not go beyond how much? Tell me. From center of gravity, load should not go beyond, not 5 meter. How much? From center of gravity, load should not go beyond 2.5 meter. So, eccentricity limit is 1/6. Whereas the range, the distance where you can place the load, where load can be either this side or this side, if you add those two, that region becomes 1/3. Fully clear? That region becomes 1/3. Full clear or not? That is clear? That region will become 1/3. First, clear. Okay. Now, what I will do is, I will write the resultant stress distribution for all the cases systematically right here. Everything over. Now, for a correct, thorough understanding, I will write full sketches. I will not explain. While writing only, I will briefly explain. If clear, lastly tell me fully clear. That's all. And remember, here I will write strength of materials. In strength of materials, if I tell compression or positive, then in soil, it is pressing the soil. Last I am telling. In strength of materials, stress language, if I tell tension, in the footing case, it is lifting. Sufficient. Further, I will not tell. There is a limit. See now. Start. One by one. See, first I will do one thing now. Consider. See, I will do one thing now. I will put purely cross section like I put 3-dimensional sketch. 3D sketch to make clear. This is a 3D sketch. S1, S2. And as usual, I will put S1, S2 somewhere here. You have this is small sketch because big sketch coming now. This is S2. 3D. This is S1. And axis 1, axis 2. Over. See now. I write one by one. Load anywhere along 1, 1. Red color. Fully visible? Tell me. Board fully visible? I don't know whether board is fully visible. Board fully visible or not? Load along 1 1. The board, okay, yes. Now, see, along 1 1. I'll first finish this case. Okay, now, then remember, when load is along 1 1, your E is along 1 1. Along 1 1, but your M is about 2 2. About 2 2. And structural depth is S1. Remember, our structural breadth is S2. Sufficient. Leave it up. Now, see. See, correctly, I will put the sketches here. Lot of sketches are there. See, I will put case 1. Case 1. Eccentricity less than S1/6 of S1. 1/6 of S1. Case 2. Case 2, I will put here. Case 2, eccentricity equal to 1/6 of S1. Case 3 here. Case 3 here. Eccentricity is more than 1/6 of S1. This is danger in case of footing. That's all. Remember. Danger in case of footing. Now, see here. I will put double sketches here. See. See, correctly tell me. If this is the sketch here, see, this is the axis. Now 1 1 2 2 I will not write. If the load is somewhere nearby here, that is what? It is within 1/3. See here. Somewhere here. Very near to axis. Small eccentricity. See, this is less than 1/6 of S1. Then your pressure diagram will be here. See, then these two edges are discussed. Here maximum pressure, not pressure, here compression. Here you told compression and constant here. This way constant. This is P/A plus M/Z. And here it is, that is compression. Here also compression. See, same way is this way. This is P/A minus M/Z. Full compression. Full compression or plus and plus. Plus, or you can write this way, means later full positive, later full positive. If the load is this side, or see, same way, I will sit down to understand. Same way here. Who knows? Lot of work is there. If the load is this side, okay, no problem. If the load is here, again P is here, this side eccentricity, then this is maximum compression. Here lesser, this way. Still compression, this way. This is, if I show upward, it is compression. If I show downward, it is tension. Or in case of footing, if I tell upward, means upward pressure. Soil is compressed. If I pull downward, there instability. Okay. This is P/A plus M/Z. This is P/A minus M/Z. Same here. Same thing anywhere here also. I don't put ABCD now. Or second case, see. This is when the load is that side or when the load is this side. Or second case. Only plan. See. I will draw the axis. Whatever this length, load will reach here. See, now I will write here. This is, I written here, see, E within, this is your E. This is your E. E equal to 1/6. Then here maximum compression, same compression here. I will show upward or later positive. It is P/A plus M/Z. Here correctly 0. Still compression, full this edge 0. Or if the load reaches somewhere here, P, this is your what? This is your E. That E equal to what? 1/6 of S1. Then this side is maximum compression P by A plus M by Z maximum. Here 0. Okay. Here full 0. See, no value. Nothing here. Empty. Nothing here. Last case. I am discussing about what? Okay. If the load is too much this side, P, high eccentricity, danger. If the load goes beyond this way, this is in problem. Then the resultant stress will be, I think, now I have to project it. No other 1 meter here. Okay, I'll do one thing. Okay. Maximum compression here. Here also maximum compression. This is P by A plus M by Z. Here it is later positive. Here there will be tension. See the arrow mark now? It will keep on reducing somewhere here. I will put arrow mark here, tension. Later this is going to be negative. Here it is not P by A plus M by Z. It is not P by A minus M by Z. Now M by, see here, in this case, P by A is more than M by Z. Here, P by A is equal to M by Z. Here, P by A is less than M by Z. Now M by Z bigger, so this will become M by Z minus P by A. Okay. Or see that way, then it is compression. See here. Up to this portion compressed, this is lifted. Or same way, if the load is other side. Okay. You show me a place where they will give this much diagram. Still not over. See, if the load is somewhere here, I am talking about load moving along 1-1. High eccentricity. See here. This side high eccentricity. Then this side, here compression. P by A plus M by Z. And somewhere here up to there compression. Compression. So that is later positive. And here tension. And here lifting or tension. Later negative. And this value is M by Z minus P by A. Okay, this is one round. This is when the load is moving along 1-1. You go through this one. If fully clear, tell me, I will put second round when the load is moving along 2-2. There, I will not explain too much. I will take a small 5 minutes break. You correctly go through. If any mistake is there, let me know now only. Why? Let me know, because later I don't want to record once again. Just to go through. See 3-dimensional sketch. And see 6 diagram drawn here. I'll take a small break of 5 minutes. By that time you watch it. Then I will write another 6 diagram. When load is moving this way. Then I will tell you about that core or kern distance. Central portion where you should place the load so that biaxial also no lifting takes place. That is actually called, see, this way. If you place the load anywhere here, actually remember, I don't want to tell, one online person told, he is a mechanical person, he is taking strength of material, he told, see, Hindi will tell, घर में अपना कॉलम लगाते हो, इसके अंदर जहां भी कितना भी लोड डालो कॉलम को कुछ नहीं होगा. What a statement. He should have told, wherever you place the load here, tension will not come. Is correct. But he told other way, wherever in this portion you are and how much load you place, column will never fail. Oh, that is, then do one thing. For a small column, centrally apply 1 crore ton. Why? Within the kern. Clear now? He told in Hindi language, इसके अंदर जहां भी लोड डालो टेंशन नहीं आएगा. That is correct. High level people. But what he told is not civil, is mechanical. He told is, इसके अंदर जहां भी और कितना भी ಕ್ಯಾ ಕುಚ್ ಬಿ ಹಿಂದಿ ಐ ಡೋಂಟ್ ನೋ. ಹೌ ಮಚ್ ಕನ್ನಡದಲ್ಲಿ ಎಷ್ಟು ಬೇಕಾದರೂ ಲೋಡ್ ಹಾಕ್ಕೊಳ್ಳಿ. ಹೌ ಮಚ್ ಲೋಡ್ ಯು ಪುಟ್, ಕಾಲಮ್ ವಿಲ್ ಬಿ ಸೇಫ್. ಓ, ದಿಸ್ ಈಸ್ ಟೂ ಮಚ್. It will fail by compression. He tells in this region you can put any amount of load. In a complete building you can put it, provided what? The load comes in that current portion. Clear now? The statement, how it's dangerous. It is how dangerous statement. He told wherever you put the load, tension will not come is correct answer. But he told wherever you want and whatever load you put, any load, he told जितना भी लोड डाल दो, कॉलम को कुछ नहीं होगा. कॉलम को कुछ नहीं होगा. Clear or not? Clear now? What is the mistake there? The second part is wrong. It will fail by crushing them. Tell me, clear or not? The second part of the statement is completely wrong. If he hear this one, he should rectify it. He should think, oh, I told Khatarnath baat. Why? No reply. Clear? You can place anywhere there, tension will not come. But you tell, anywhere you place, any load you can place. 1 ton, 10 ton, 1000 ton, 1 crore ton. Entire earth you place on that one. According to him, if the load is in the middle, that 1/3 portion all round, nothing will happen. Nothing will happen. So, in case of RCC footing, if the column is coming at exactly center, you can put any load. See, entire building you can put only 1 column according to him. But then pressure will exceed SBC. See, but lifting will not come. Okay, I'll take 5 minutes break now and I'll come back and write all the second round cases. Just 5 minutes. Okay, just to go through this one. If any mistake is there, find it now. At least some work for you. You correctly observe. In case any mistakes are there, if any mistake is there, let me know, so that I do not want to record once again. Okay, 5 minutes time. You seriously go through everything and tell me if any mistake is there. Mistake means what? Not technical mistake, writing mistake. Technical mistake will not be there. Okay, fast. Okay, I am back. But tell me, voice clear? You have to confirm. Fast comment. I will put the sketches. So that complete, there is nothing left out. Voice clear? If voice clear, I will go for next round sketches. Fast tell me. Is the voice fully clear? Clear. Okay. Now see. Now I will not explain. I will only write. I will use blue color now because. Okay. Now see. Now I am going load anywhere along 2 2. E is along 2 2. M is about 2 2. Okay. Now you are load. I use red color only for that one. I will write the blue color now full. After everything is over, you just comment clear or not. See, I am not saying anywhere. Load moving along 2 2. E is along 2 2. But M is about 1 1. This way. Then your structural depth. Structural, okay, spelling problem. Structural depth is S2. And your what? Structural width becomes S1. Therefore, all eccentricity is in terms of S2. In terms of S2. Okay, I'll write here. One by one case, I'll finish all the cases now. Just everything correct. Any mistake is there? Tell me, by chance any mistake is there? Later I have to repent. I don't have to repent once again. Any mistake is there? All correct. Mistake means print mistake. What I wrote earlier down. Was there any print mistake or no mistake? No. What I wrote earlier, have you gone through? Any mistake? So that later I don't want to record once again this also. You are not answering. What I wrote earlier, you found any mistake? Mistake possible only what? Writing mistake, print mistake I told. Okay, start. I'll write brass now. See. Case 1. Case 1. Your eccentricity E is less than S2 by 6. Case 2. Eccentricity E is equal to S2 by 6. Case 3. Eccentricity is more than S2 by 6. Danger. Danger in case of footing. Column no problem. It can take tension. Column no problem. Footing danger. Okay. If you want write entire contact area, entire cross section compression, one side maximum compression, one side zero, one side compression, other side tension. Now reference is these two edges. Now our referring edges are these two. Sorry, A, B, C, D. If I tell A, B, C, D, now our reference is these two edges. Our variation is for these two edges. Variation along S2, but variation constant along DC and AB. See, now. Axis 2 2 1 1, I am not writing. Or or 2 2 1 1 you write. What is this one? Or atava load it other side. Now your E is along this way. Small eccentricity here. Or here. This is your E. This is your E. Small here. Then this side is fully compression. Maximum compression. This side is what? Compression still. Compression. I will put here. This also compression. See, it comes this way. Full here, same. I will put only arrow mark, sufficient. This will be compression, this also compression. Okay. Plus minus I won't write. Values you know it. What? Why should I write? P by A here. What happened here? Cut. This is P by A plus M by Z, and this is P by A minus M by Z. Or if the load is here, then this side is full compression, maximum. Compression. Okay. Compression. Here, come lesser. It will reduce here. This is P by A plus M by Z. This is P by A minus M by Z. Okay. Here, if the load reaches somewhere here, correctly, 1/3 S2 by 6 here, little inside. Either S2 by 6 here or S2 by 6 this side. Load is here. I have not written P actually. Okay, P. Then here, maximum compression. And when you reach here, it will become 0. See? Compression 0. Nothing here. Along this edge, no stress. Along that edge, maximum compression P by A plus M by Z. Or here, what happens now? Along this edge, maximum compression. Compression later. It is P by A plus M by Z. Here, 0. It varies, then becomes 0 here. Still compression. Here, if the load is too much on that side, beyond the limit, then this side will get lifted. See? Lifted. That is tension. Here, tension, it will become 0 here, then compression. This is P by A plus M by Z. This will be what? M by Z minus P by A. This is tension of item. This is compression. Or if the load is too much this side, then this side is full compression. Compression later. P by A plus M by Z. Here, compression, it will become, I should write this way. Okay. This way. This will be tension. This will be still compression. Out of scale. Okay. Now, this is compression, and this will be M by Z minus P by A. Sufficient. 3-dimensional sketch, I am not expert. At least. Now, fully clear. This is when E is within S2 by 6. When either side E is equal to S2 by 6. When either side E is beyond S2 by 6. And here load is in the middle 1/3 portion. It is exactly came to edge of 1/3 portion. It is gone beyond the middle 1/3 portion. Now, when the load is moving this way, BM will come this way or this way. Structural depth is S2. Is the structural depth. Structural breadth is S1. All eccentricity measured along S2. Measurement is along 2, but BM is about 1. Tell me, is all right here? If fully clear, tell me all clear. One comment. All clear. So that no doubt should come later. Just one comment I require. All clear. Don't tell all clear just to please me. Don't tell all clear just to please me. You should tell from inside. All clear. Okay, thank you. Now, next, that core portion I will tell next time. And next time, I will close this complete chapter. I will give an example of either a retaining wall or what? Sorry, 1 minute. First, I will convert this column problem into footing problem. That actually I should not tell because in the RCC class, it is already over. First of all, not required. Actually, even general public also, they can refer my RCC class, it is there. But still, no, let it be here. I will change over to footing case. It will take only 1 hour. That's all. Not 1 hour. Half an hour. Why? I will write earlier only. Then I will take one small example of a masonry dam or retaining wall and show you how the pressure will come there. Okay. Clear. See you next class on Tuesday. There is a class 7. It will be closing. We will close that one. Then Wednesday, we will start a new chapter, deflection. Okay. Thank you.